Good morning, friends. I, Dr. V. M. Tidke, Sanjeevani College of Engineering, Department of MBA, welcomes you all. Let us continue our studies of Unit number 2 under Decision Science. Today, in particular, we are going to learn various terminologies in transportation problem. So, at the end of the session, every student will be able to understand the various terminologies used in transportation problem. Friends, by the time now the idea is very clear that transportation is a kind of statistical tool by which you can make the decision regarding optimization of cost in the process of moving materials from one place to another. I explained you already that if there is a company having a plant located at three regions, say Mumbai, Delhi and Kolkata, whereas the entire country is using the products that have been manufactured in these three plants and the demands of different areas are varying. So, with the help of transportation, you can properly manage the movement of goods from these three manufacturing centers to the demand points. And in the process of that, it ensures a lot of investment in the transportation cost. So, with the help of transportation in statistics or in decision science, you can better arrive at a choice by which your cost of transportation would be minimized and your delivery at the right point of time in the right quantity would be ensured. So, let us learn the different terminologies under the same. Friends, the first terminology is you can see there is a transportation table. It's a transportation matrix, more popularly we call it as. You can see in this picture there is row wise there is a plant. So there are three plants, that is one at Bangalore, another one is at Hyderabad and another one is at Kolkata. Whereas there are three warehouses, one is at Mumbai, another one is at Pune and another one is at Ahmedabad. Friends, you can also see there is a one column telling supply and another column telling about demand. So a demand is nothing but the entire demand of that particular product throughout the nation, whereas supply is the total capacity of manufacturing of all the plants. Okay, now if you will put the values of all of this into a matrix, we call this as a transportation matrix. In this particular transportation matrix, you can see several numbers. Say for example, there are few numbers which are written in the oval shaped yellow colored box having values like 70, 60, 60, 60, 80 and 50. Whereas there are other values which are kept on the upper right hand side corner of the box valuing 10, 10, 10, 10, 10 and 10. So we need to be very clear regarding what are these numbers and what do they indicate. So firstly, everything that is written in that oval shaped yellow colored boxes, the values are nothing but the number of units that are getting transferred from a plant to warehouse. Whereas the value which is mentioned on upper right hand side corner of that box is nothing but the cost of 1 unit's transportation from the plant to the warehouse. Okay, now let us try to understand. In this particular case, if you will see the sale 1, which is indicating the box with a value 70 and a cost with a value 10. So it means that from a plant which is located at Bangalore, 70 units are being transferred to a warehouse which is located at Mumbai. And for transferring 1 unit of product from Bangalore to Mumbai, it costs rupees 10. Are you getting this point? Okay. Now you can say it from second sale. There is a value 60 and 10. It indicates that from the same plant, that is Bangalore, a company is going to transfer 60 units to Pune warehouse, whereby the cost of transportation from Bangalore to Pune is rupees 10. Similarly, if you can see from third sale, there is a dash and 10. So it indicates that from Bangalore plant there is no supply to Ahmedabad warehouse, whereas the cost of transportation per unit is rupees 10 from Bangalore to Ahmedabad. And similarly, you can get on the understandings of the remaining values that are mentioned here associated with various other plants and other warehouses. Okay, so this is the transportation table. Now moving further, the first terminology is a balanced transportation problem. When we do call something to be a balanced transportation problem, if the total supply is equal to the total demand, then we call that transportation table to be a balanced transportation table. Say for example, in the similar problem, you can see the total supply from Bangalore is 130 units, the total supply from Hyderabad is 120 units, and the total supply from Kolkata is 130 units. If you will add all of this supply from Bangalore, Hyderabad and Kolkata, it comes to 130 plus 120 plus 130, that togetherly combines a number called 380. Whereas if you will see the demand at various warehouses, Mumbai is having a demand of 210, Pune is having a demand of 60, and Ahmedabad is having a demand of 110. So if you will add the total demand, that is 210 plus 60 plus 110, you will get a number called 380. In this particular transportation table, the total supply is 380, whereas the total demand is also 380, and that is why this table is a balanced transportation table. Okay, now the second terminology is unbalanced transportation table. Now you can clearly understand what do you mean by the unbalanced transportation table. So an unbalanced transportation table is simply a table whereby the total supply is not equal to total demand. Either demand is more or supply is more, but they are not equal. If this is the case, we call that table to be a unbalanced transportation table. Is it clear to you? Friends, before moving further, let me clear it one more time that anything which is written in the center, in the oval shape or in the circle shape, in this table it is mentioned with a yellow color, it is a number of units to be transferred from one destination to another destination. Whereas anything which is written on upper right hand side corner, remember upper right hand side corner, that is the per unit cost of transportation from destination 1 to destination 2. So you have to remember this. Okay, now moving further, just to get on the understanding of another terminologies, there is another terminology called dummy source or a destination. A dummy source or a destination is a dummy row or a dummy column having zero transportation cost per sale to be added in order to balance the transportation problem. Friends, to move into transportation problems, we every time requires a balanced transportation problem. So if in the problem, if we will find that there is some transportation table which is not balanced, so in that case we have to make that table to be balanced with the help of adding either a dummy row or a dummy column. Then what is dummy row or dummy column? Dummy row or dummy column is nothing but a row or column having zero transportation cost but will give you the additional demand or supply units to balance your total transportation table. Okay, now moving further, initial feasible solution. Initial feasible solution in case of transportation table is a solution that satisfies the demand and supply conditions, and yet it may or may not be the optimum one. Okay, so initial feasible solution is actually satisfying your demand and supply condition, but that may not be the minimum possible costing. I will give you an example. Say there is a company having two plants and two destinations where product is being sold. Say at Mumbai and Pune they have a manufacturing plant. Okay, और ये प्रोडक्ट सेल कहाँ पे होता है? एक जाता है हैदराबाद, दूसरा जाता है दिल्ली. ओके, अब मुंबई और पुणे में बनता है और हैदराबाद और दिल्ली में सेल होता है. समझो मुंबई से दिल्ली जाने के लिए 10 रुपया कॉस्ट लगता है और मुंबई से हैदराबाद जाने के लिए 20 रुपया कॉस्ट लगता है. ओके, एंड पुणे से दिल्ली जाने के लिए 15 रुपए कॉस्ट लगता है और पुणे से हैदराबाद जाने के लिए भी 15 रुपए कॉस्ट लगता है. तो समझो कि दिल्ली में 50 यूनिट का रिक्वायरमेंट है और हैदराबाद में 20 यूनिट का रिक्वायरमेंट है. तो बेस्ट कॉम्बिनेशन क्या होगा? आप ऐसे सोल्यूशन की तरफ आएंगे जिससे कि आपका टोटल सप्लाई भी पूरा हो जाएगा दिल्ली और हैदराबाद का और आपको कम से कम कॉस्ट लगेगी. लेकिन ऐसा भी तो पॉसिबल है कि आपने ये पूरा का पूरा जो यूनिट है वो मुंबई से ही सप्लाई कर दिया, तो मुंबई से आप दिल्ली को दे रहे हो, मुंबई से भी आप हैदराबाद को दे रहे हो, या पूरा का पूरा आप पूना से ही सप्लाई कर रहे हो, पूना से दिल्ली और पूना से हैदराबाद, या फिर एक यूनिट आप मुंबई से हैदराबाद दे रहे हो, दूसरा यूनिट आप पूना से दिल्ली दे रहे हो, ये भी पॉसिबल है, या फिर आप मुंबई से दिल्ली दे रहे हो और पूना से हैदराबाद दे रहे हो। तो ये जो भी कॉम्बिनेशंस है ना, ये सारे कॉम्बिनेशंस आर नथिंग बट द इनिशियल फिजिबल सॉल्यूशंस। तो इनिशियल फिजिबल सॉल्यूशन वो सारे होते हैं जो कि आपके डिमांड और सप्लाई का कंडीशन को सेटिस्फाई करते हैं, पर उसकी जो कॉस्टिंग है वो ऑप्टिमम होगी या नहीं बोल नहीं सकते हैं। ओके, तो लेकिन जब हमारे पास ये इनिशियल फिजिबल सॉल्यूशन होता है तो उसको कैसे हम आइडेंटिफाई कर सकते हैं? सो टू आइडेंटिफाई द इनिशियल बेसिक सॉल्यूशन यू हैव टू हैव द थ्री मेथड्स। द मेथड्स आर नंबर वन, नॉर्थ वेस्ट कॉर्नर मेथड which is more popularly known as NWCM method. Number two is matrix minima or list cost method, we call it as a LCM method, and third is a WAM method, that is Vogel's approximation method. Okay, so this is the initial feasible solution and the methodologies by which you can arrive at them. I repeat, there are three methods: NWCM method, that is northwest corner method; number two, that is matrix minima or least cost method; and number three, that is Vogel's approximation method, that is WAM method. Okay, moving further, let us try to understand the optimum solution. Optimum solution is a feasible solution which also gives a minimum cost of transportation. ओके, सो ऑप्टिमम सोल्यूशन वो इनिशियल फिजिबल सॉल्यूशन में से ही एक होता है जिसकी कॉस्ट मिनिमम होती है, एंड दैट इज अवर टारगेट्स. ओके, so that is the optimum solution. There are two methods by which you can get an optimum solution. Number one is stepping stone method and number two is modified distribution method, or more popularly MODI method. Okay, so these are the various terminologies under the transportation table. Okay, I hope you have understood the video, and if yes, then kindly list down and explain the various terminologies used in transportation problem. Thank you for watching the video. If you have any doubts, you can contact me on below mentioned details. Thank you for watching. Have a nice time.